So in this part of the chapter, we're just going to look at some solving some problems involving logs. So just example 14. Three to the x equals 20. Okay, so what 3 squared is 9, 3 cubed is 27. So you know the power is going to be somewhere between 2 and 3, but what's the exact value? Well, we can now use logs to solve that problem, because 3 to the power of on the other side becomes log to the base 3. So x equals log to the base 3 of 20, which you can smash into a calculator. (2.72616 decimal places), 2.727. Okay, B, we have 5 to the power of 4x take away 1 equals 61. Okay, same here, 5 to the power of becomes log to the base 5. So we get 4x take away 1 equals log to the base 5, 61. And then minus 1 moves over to come add 1, or add 1 to both sides. And just be careful here that you don't change that to log to the base 5, 62. It's not, it might be helpful to put that in brackets maybe, or just don't do it. And then divide by 4, log to the base 5, 61 plus 1 over 4. And one thing you can do is put the plus 1 at the start, so it's 1 plus rather than at the end. Okay, you can work that in the calculator. .889. You can go back and check that, so put 0.889 into here, 5 to the power of, you can stick that in, you should get 61. Okay, example 15. We're given 5 to the power of 2x minus 12 brackets 5 to the power of x plus 20 equals 0. Now it kind of looks like a quadratic equation. If I rewrite it like this, it makes it more obvious that it is a quadratic equation. So I'm going to swap 5 to the power of x for y. So I've got y squared minus 12y plus 20 equals 0. You'd expect it to factorise. So 10 and 2. So y equals 10, y equals 2. But remember, you weren't after y, you were after x. So I've got 5 to the power of x equals 10, 5 to the power of x equals 2. That's going to move over as log to the base 5. So x equals log to the base 5, 10. X equals log to the base 5, 2. Now you need to read the question carefully, because it might say find the exact value. So you'd leave it like that. But I think on this one it said it wanted to 3 siggy figures. No. So 1.43. 0.431. Okay. Example 16. Just try and squeeze that in here. Right, we've got 3 to the power of x equals 2 to the power of x plus 1. Now, with a question like this, you've got to know the first step. If you don't know the first step, you haven't got a clue. Obviously, this chapter involves logs. The way to solve this problem is to use logs. So the first step is to log to any base you like. I'm going to do, say, base 2, but as long as it's the same base, it doesn't matter. So log to the base 2, 3 to the x equals log to the base 2, 2x plus 1. So providing you've got the same base, you can use whatever base you like. Now, on both of those, I'm going to bring the power in front. So I've got x times log to the base 2, 3 equals x plus 1 times log to the base 2, 2. Now, I inadvertently I've had a slightly quicker way of doing this, because log to the base 2, 2 is 1. So I've got x log to the base 2, 3 equals x plus 1. I'm now going to bring this x over as subtract. I can now factorise x out. And then that comes across the divide. Now that only worked out a little bit more easily because by chance I picked log to the base 2 and then those cancelled to give me 1, which was just a fluke. So 1 over 1.70, what did I want, 4 decimal places, 1.7095. So that's all the examples on that section. So if you now have a go at exercise 14F.